Thank you for joining me on this online presentation. Today I'm going to talk about a new project we are working on called AIFlow, and I'm going to show you how can it closely work with Apache Flink to make AI easy. Before we start, a little bit about myself. So my name is Becket, and I'm currently working in Alibaba on Apache Flink. And prior to that, I worked at LinkedIn on Apache Kafka. And I graduated from Carnegie Mellon University and worked on mainframe in IBM before also. And right now I'm a Apache Flink PMC member and I'm a Apache Kafka PMC member as well. Cool. So yeah, let's take a look at the agenda of today. So first I'm going to talk a little bit about what is AIFlow and what is the problem AIFlow is trying to solve. And then we're going to dive a little bit deeper into the AIFlow itself. We're going to see how exactly we implemented and designed AIFlow so it can solve the problems that we mentioned earlier. And then I'm going to talk about Flink AIFlow to show you how Flink and AIFlow can work together so well that helps solve a lot of problems. And finally, we're going to have a summary. So what is AIFlow? Before we introduce AIFlow, we want to take a look at the AI workflow where you want to define a bunch of things when you do AI. And then we're going to look at the challenges when you do that. Then we'll see how AIFlow can help you. So for anyone who works with AI, they probably need to have some kind of workflow. And everything starts with data. So you will have a lot of data sources to store your data. It could be Kafka, like a streaming source, and it could be HDFS or Hive, for batch sources. So in any case, you will have a lot of data sources. Now you have the data. What you are going to do is that you're going to try to train your model. So you will have a training pipeline like this. It starts with data acquisition. So you will first get data into the pipeline, do some pre-processing, then you feed it into the training component to train your model. Once you get a model, you're going to test and validate it. Now you will have the model. So what I want to do is to use the model. That means you're going to deploy it to an inference pipeline. So, and the inference pipeline also starts with data acquisition and then do pre-processing, just like the training pipeline. And after that, it's going to feed the data into inference component where you have the model there, and it takes a look at the unlabeled data and do the predictions to put the label there. Okay, so is that enough? Probably not, because you don't know whether your model works well or not. So you need to know how precise the prediction is. So what people usually do is that you also need to add some monitoring to the workflow. So you're going to say, okay, I'm having my model monitoring to see how good my model is, how precise my predictions are. And you also need to monitor the examples that fit into your inference pipeline to see whether the distribution of the samples or distribution of certain feature fields has changed or not, because you want to make sure those distributions are exactly the same as the data set that you used for training when you get the model earlier. Okay, so and in order to get the entire thing running, you need to have something to help you, and that's a workflow. So a workflow usually contains two parts. One is the workflow definition, and the second part is workflow execution. So the workflow definition means that you need to define two things. One is the node in the workflow, and the second thing are the relations among the nodes in the workflow. So, and in most cases, the nodes we're talking about here are just jobs. And the relation can be simply described as finish before relation. So what does that mean? That means that when you define a workflow, what you're essentially saying is that I want this job to finish before start the next job, right? So this is a finish before relationship among the jobs. And based on this workflow definition and semantic, when it comes to the workflow execution, you will have a scheduler which is based on the job status change. So, and it will look at the job status to see whether this job finishes or not and decide what to do next. Okay, with that, let's keep that in mind and take a look at the following challenges. So the first challenge we're facing right now here in this pipeline is how can we make offline and online paths to collaborate with each other. As a concrete example here, when you're doing inference, in most cases, you're providing some online services. So your inference will be a long-running job. It's going to run forever. And your model training is not going to run forever. Likely, it's going to be like a periodically running job, generating model every day, let's say. Now, after my model is generated, I want to push it to my online inference job, right? So what can I do here? I mean, the workflow says that it only deal with job status change. So now after my model is generated and validated, what should I do with my online inference? Should I restart the inference job, or should I just let it run and do a dynamic model load? So it's pretty much undefined area for the workflow, because the workflow only deals with the finite jobs, pretty much. Right? It's a finish before relation. So when the job finishes, I do something next. But for a long-running job, it doesn't know what to do. So that's the first thing. And the second thing is that sometimes you want to go one step further and to make your training pipeline also to be online training. So in this case, the training component itself is also going to be a long-running job, and it's going to generate model every, let's say, 5 minutes or maybe half an hour. So in this case, once my model is generated, what should the workflow do? Because the training job is a long-running job, and ideally, after it generates a model, I should start a test and a validation job, right? However, because the training job never finishes, it's just a long-running job. So the workflow based on job status change will not be able to know when to kick off the test and validation. So as you can see, both cases here reveals one issue, which is the current workflow just doesn't deal with streaming jobs quite well. Okay. All right. And in addition to that, we actually have more issues in this workflow, or more challenges in this AI workflow. So one thing that, as we mentioned, we have a lot of data sources here. So dealing with so many different data sources could be pretty challenging. And also, a lot of components may run in different environments or platforms. So for example, some of them might be running in Yarn, in Kubernetes, or in some managed cloud services. So in order to make everything work well, it could be pretty challenging also. And lastly, we might leverage different computing engines in the workflow. For example, for offline preprocessing, you might be using Spark, and for the offline training, you use TensorFlow. For online preprocessing, you use Flink, and inference, you use TensorFlow again. So it might involve a lot of different engines in your workflow. That could be quite challenging to deal with also. Now, with AIFlow itself, we're trying to deal with at least 4 out of 5 issues were mentioned here. And how? So let's see what AIFlow provides. So first of all, AIFlow provides native support for real-time AI. That means it defines workflow with streaming jobs. Remember, we just mentioned that currently most workflow doesn't work well with streaming jobs that never finishes. Okay, the second thing is that it's adaptive to various engines. So you can run simple Python ground programs, you can run Flink, Spark, TensorFlow, PyTorch, etc. in it. That's fine. And it it doesn't specify, it doesn't bound with any platform. You can run on Kubernetes, on Yarn, or cloud service also. So it's pretty flexible. So that's pretty much what AIFlow is trying to do. It tries to provide support for streaming jobs within a workflow and try to adapt to various engines and try to be platform agnostic. Okay, with that, let's take a look at, let's take maybe a closer look at AIFlow and see how exactly did we do to make it work. So first, let's take a look at a brief introduction. So AIFlow is, like I mentioned before, it's a top-level workflow abstraction for big data and AI, especially for real-time AI. And what's a key difference that we made there? So one thing we made different is that when we do the workflow definition, we make the node, instead of being jobs, become logical processing units. And instead of letting the relation to be happen before relation, we make it event-driven conditions. So what does that mean? That basically means that if you want to run this logical processing unit, you will need to specify the condition instead of saying, okay, it's just happened before the previous one finishes. And for scheduler, we have to change it as well. We have to change it from the job status-based scheduling to event-based scheduling. So when you receive a few events and your condition is met, then you can do the next thing. So that's a key abstractions we made underneath. And in order to make it work well for AI and all the scenarios, we also need a few supporting services. So, and here we mentioned three services. One is metadata service and notification service, and the third one is a model center. So what are they? So metadata services help us to manage the dataset. So you can register your dataset into metadata services and reuse them all the time without registering them again. And it also allows you to register projects, so you can do you can easily reproduce your result with a registered project. And it's similar for workflows and jobs, so it's easy for you to backtrack or backtrace what happens in that particular execution, which workflow did I run to get a job, to get a model, and which jobs are there, and check the job history, so on and so forth. And the model lineage basically means it will tell you which particular projects, which particular execution of that project actually generated this model, or actually is associated with this model. And the artifacts is a pretty flexible format where you can store pretty much everything there and just to give it a name. Okay, so this is for metadata service. And for notification service, this is actually pretty critical for us to implement the semantic. So the basic idea of notification service is very simple. It allows you to register listener based on an event key, let's say model. And then somebody else might say, okay, I want to update the model key with a value model URI. And then you will receive an event notification saying that there's a new event, and the key is model, and the version is number 1, and the value is model URI. So with more updates coming, you will receive a higher version of these events with the same model key. So this is a pretty simple abstraction for notification service, but it's critical in our implementation. And finally, we have model center. That's a kind of pretty standard way to maintain the information about the model. So we will do model versioning. You have a lot of version of the same model, and you will have parameters of the model, metrics of the model, and we'll manage the life cycle of the model also. And we will also provide visualization for the models. Okay, with that, let's take a look at the architecture of the entire AIFlow. So we can divide AIFlow into two major parts. One is AIFlow SDK. So this part is essentially doing the define and the compile. So, this is essentially the workflow definition part. And the second part is AIFlow service. AIFlow service is essentially a part where we use to execute the workflow. So that's the workflow execution part. So we're going to walk through everything piece by piece. So first, on the top, we have a config AIFlow API and dependencies. So what you do with those three components is that you just define an AI graph, which consists of AI nodes and the relations. And you can also put configs and dependencies to the AI, for the AI nodes as well. And the AI nodes, like we mentioned before, are named logical processing units with multiple inputs and outputs. And the AI nodes are going to be interpreted by a module called job generator, and we will talk about that very soon. And the relation in the AI graph can be twofold. One is data dependency. So the data dependency essentially are data flows to be interpreted by the job generator. So note that the data dependency doesn't define the boundary of a job. It's usually inter-job, but not inter-job. On the other side, control dependency is an inter-job dependency. And it essentially tells the scheduler what to do once the previous job finishes. So this defines the job boundary. So what exactly does that mean? Let's take a look at this example. So here we have an AI graph, and all the circles here are AI nodes, and all the like black edges are data edge, or data dependency, and all the red edges are control edge. And in this case, we have two control edges, and we have a bunch of AI nodes and a bunch of data edges connecting everything together to become a workflow. And when you start to run this workflow, the first thing we're going to do is that we're going to register the job and execution to metadata service. And the purpose of doing that is that later on, if you want to say, okay, I like this result, I want to reproduce it, we can easily fetch everything from the registration and reproduce it for you. Okay, now let's move to the second part. After you define your AI graph, we need to translate it into a workflow. And that job is done by a component called job translator. So the job translator works in two steps. The first step is split. So basically chunks AI graphs into subgraphs. And the second step is translate. It translates each subgraph into a job. And that work is pluggable and done by the job generator. As we mentioned before, the job generator will have a few inputs, including the AI node, the data edges, and also the configs. Okay, so let's also take a look at the previous example. So what essentially done by the job translator is the following. So with this graph, it takes a look at the control dependencies and chunk the graph into three pieces. And then it applies the configs to each of the piece and forms three jobs. Okay, so that's pretty much what the job translator does. And in terms of how those subgraphs are turned into the jobs, that is done by specific job generator, which is engine specific. So that means job 1 might be a Flink job, job 2 might be a Python job, and job 3 might be a Spark job. And they might be translated by different job generators corresponding to their engines. So in order to do that, in the code, you would do some definition for execution blocks. So here, for example, we have a basic global config saying the engine is Flink. And then later on, we can just provide a job config, and then it defines a Flink job. And later on, you may say, okay, I want to change the engine to Python. And what you do is that you say with AF engine Python, and then this job becomes a Python job. And when you go, when it comes out of this execution block, the global config takes place again. And when you do the AF job config, it will become a Flink job again. So, okay. And after the job translator generates the workflow, it goes to the AIFlow client. The job of the AIFlow client is to turn a workflow into an executable workflow. In order to do that, the AIFlow client will first upload all the code and dependencies to a remote store, and then get the URI back. And it will put the URI into the workflow to make it executable workflow, which means that you have a workflow and you know where to find the code and dependencies. So again, to illustrate that, now we have a workflow, and what we do is that we're going to find a remote store for executables and dependencies. And we're going to upload everything to it, and we're going to update the URI in our workflow and make it an executable workflow. Cool. Now it finally come to the second piece of AIFlow, which is the execution part. The execution part is served by something called AIFlow service. It contains a lot of subcomponents. For example, the REST endpoint to accept the workflow, and it contains all the supporting services we mentioned before, and also a component called deployer, which inside we have a scheduler, job submitter, job status listener, and so on. So, but after all, the main purpose of the AIFlow service is to just run executable workflows. It will schedule the jobs and submit jobs to different platforms. Okay, so how exactly would it be done? Let's take a look at a pretty concrete example. Let's see. So assuming that the AIFlow service has received the graph that the workflow that we have just mentioned, the first thing it will do is that it will schedule the first job. So it will update the job status in the metadata service, saying that I'm going to start the workflow execution with the first job, and then it tells the job submitter, okay, go ahead and submit this job 1. And we're just assuming that currently the platform is a Kubernetes cluster. So it's the only environment is Kubernetes. Now you have job 1 running there. So the job status listener will see, okay, job 1 becomes running, and it will just fire an event to the scheduler, and the scheduler will just update the job status. Okay, and what happens next is that the job 1 is a model training job. It will train a model, and it will register a model version to the model center. And the model center will then tell the notification service saying that, okay, this particular model has a new version coming out. And this will trigger the notification to the scheduler, because scheduler is listening to that model key. And once the scheduler noticed the new model version has been generated, it will take a look at the control dependency it has, and it will notice, okay, the next job need to be run after receiving this event would be the validation job. So what it does is that it schedules the next job, which is a validation job. Now the validation job runs, and let's say after a while the validation has passed. So a model version has been validated, and that event goes to the model center. So the model center will tell the notification service, okay, I have this model version validated event. And that event will go to the scheduler again. And the scheduler will look at the event key saying that, okay, model version validated, this key means that if this key, if I receive an event from this key, that means I need to either start running the inference job, or I need to tell the inference job something. Okay. And in this case, it will notice that the inference job hasn't started yet. So what it does is that it's going to, by the way, the validation job itself is actually it's actually a batch job. So you generate a model, you validate it, and the validation job is just gone. And the scheduler would start to schedule the next one to, it will start the next one, which is the inference job. And the inference job will just take a look at the model center and get to the latest model version that has been validated. Okay, and later on, let's say this job one, it's a long-running streaming learning job, and it generates yet a new model version. So it registered to the model center, and the model center tells the notification service, okay, I have a new model version generated, so you need to validate again. So job two is scheduled again, and in this case, let's say job two runs again and gets the new model version validated again. And after that, job two is just gone, and it sends a notification out again. And in this case, the scheduler will notice, okay, job three is already started, so I'm not going to start it again. And job three is actually also subscribing to the same model version update key. So what happens is that it will receive the new model version validated event, and it will reload the model version from the model center. Okay, as you can see, the entire workflow here are actually driven by events, whether it's a job status change or it's other events. The scheduler basically work based on the events. Okay, cool. Hopefully this example can explain well how the workflow works with all the supporting services and streaming jobs. Now let's take a look at how AIFlow can work with Flink. So, and essentially we have something called Flink AIFlow. So what is Flink AIFlow? Flink AIFlow is an implementation of AIFlow semantics, and it contains a Flink job generator, a Flink job submitter, and you can submit to local or Kubernetes or Yarn, a lot of them. But so far we only implemented local and Kubernetes, and that's only about 1,000 lines of code in total. So it's as you can see, it's pretty easy to integrate. And Flink AIFlow works pretty seamlessly well with Flink ecosystems such as PyFlink, Flink ML pipeline, and TF on Flink. So as we mentioned before that AIFlow can cover the 4 out of 5 challenges that we encounter in AI workflow. And the last one, heterogeneous data sources, can be covered by Flink, apparently, because we have so many different connectors, right? So that's the first thing that we can think of that you can leverage Flink for. And so how Flink AIFlow work with, how does Flink AIFlow work with ML pipeline? So in this case, as you can see, all the blue tubes are ML pipelines. And the Flink job generator will basically compose all the AI nodes together and generate one single Flink job. And within that Flink job, all the pipelines are connected together to become a single Flink DAG. So that's pretty much the relation between ML pipeline and Flink AIFlow. So Flink AIFlow basically works in the higher level than Flink ML pipeline. And how does Flink AIFlow work with PyFlink? So there are actually 3 modes that you can run PyFlink jobs in Flink AIFlow. The first job, the first type is you specify the engine to be Python, and just run it as a PyFlink main function. So that's like an ordinary Python function. That also means users have to deal with I/O by themselves. So there's basically AIFlow won't know that it's running PyFlink. It just knows it's running a Python function. That's it. So that's the most generic way of running, I would say. So, and the second way is to provide a Python, a PyFlink processing function. So the PY-Flink processing function, and also you need to specify the engine to be Flink. So, and what happens is that in this case, the Flink job generator will chain the PY-Flink processing functions together, just like we mentioned before. It will group the AI nodes together and generate a single job. So in this case, Flink AIFlow will deal with AI, and the user PY-Flink processing functions doesn't need to deal with I/O at all. And lastly, you can also use PY-Flink ML pipeline interface, which is going to be available after Flink 1.11. If you use that, you specify the engine to be Flink, and everything else would be pretty much the same as a Java ML pipeline. So Flink job generator will again chain everything together to form a single Flink job. Yeah. Okay, so how does Flink AIFlow work with TF on Flink? Just to recap for TF on Flink, TF on Flink runs TensorFlow as a Flink operator in the Flink DAG. So in this case, the blue tube is ML pipeline, and inside which there's an operator, and that operator basically runs TF inside it. So as you can see here, there's a Flink job contains two ML pipeline stages. One is transform, and the other one is predict. This Flink job is going to be generated by the Flink job generator in AIFlow also. Okay, let's take a look at an example of how everything works. So let's say I have a bunch of visitors to my website, and I'm trying to show some ads to them and make them become my customer, which means they're going to pay me money to buy something. The first thing I would be wondering is that, what kind of ads should I show them, right? So what I can do is that I will try to provide a prediction pipeline. And I'm going to take a look at the visitor's page view and join them with the user profile. So I will be able to know who is visiting my website, and I'm going to predict what they might be interested in and show them the advertisement, right? And apparently this blue node, this blue circle here means it's a model. It needs to predict. So where can I get the model? It probably needs some kind of a training and a validation pipeline, right? So let's make it online learning and validation pipeline here. So inside the online learning and validation Flink job, you will have a transformer. It will transform the online the input into and split them into two pieces. One piece is going to fit into the training pipeline. That's essentially the label data. And the second part is going to the validation pipeline. It's going to be used to validate whether the trained data, the trained model is good enough or not. So, and the input of that online learning and validation job is going to also take page view event as one of the input. And it's also going to take add a click event as an input. So after that, it will know, okay, so this guy viewed my page, actually clicked the ad, and I made some money from it, right? So that's actually a positive example in my case. So with that, you can generate label data to fit into training and validation. And now how can I feed the training and validation job with the Flink job that is doing online prediction? So the way it works is that you use AIFlow. So AIFlow will basically, so let's say your training job actually generates a new model version every 5 minutes and registered to the model center. And apparently the notification service will tell the validation node, okay, a new model version has been generated, and the validation node will then, fetch the latest model version from the model center and do some validation. And assuming everything is going well, it will send a notification, it will basically register an event saying that, okay, the model has been validated. And the notification service will then tell the Flink job that is doing online prediction, saying that, okay, I have a new validated model version ready for you. And after that, the online prediction job will just, get the model from the model center. So yeah, so as you can see, everything here works well. And we have one long-running online prediction job, and we have one long-running online learning and validation job. Yeah, and one thing to mention is that usually what happens is a closed loop. So what happens is that when you feed when you provide the ads, and you will be able to know, okay, so this ads was predicted by this model, and you will once it's joined with ad click event, you will know whether that ad worked or not. So you will know whether this model is working well or not. So this is also, I didn't put the monitoring workflow here, but as you can see, it's actually also going to work if I put it here. Cool. With that, let's go to the summary part. So it's a pretty short summary. So if there's anything to take away, I hope you to remember that AIFlow is a workflow with streaming job support. And it also has supporting services to facilitate AI use cases. And it works perfectly well with Apache Flink, but also adaptive to other engines. Cool. With that, that concludes my presentation today. And we're going to open source this very soon, so keep tuned. And last but not least important, or actually it's most important, we are hiring both summer interns and full-time. So please contact me.